Now we need to solve this function. Now we can make the figure for boundary values. For boundary values as shown in this figure, we have u values, the u1, u2, u3, and u4. Now we have a solution using the Laplace. This is the solution of Laplace. Uij is equal to 1/4 times u1 plus 1j plus ui minus 1j plus ui j plus 1 plus ui j minus 1. For u1, we can get the u1 by using this figure. u1 is equal to 1/4 times u2 plus 1 plus 1 plus u3. And for u2, 1/4 times 4 plus u1 plus 2 plus u4. And for u3 is 1/4 times 1/4 times u4 plus 2 plus u1 plus 4. And for u4, 1/4 times 5 plus u3 plus u2 plus 5. We have a 4 equation. We have 4 equation, 4 unknowns. Using Gauss-Seidel method, first we need to take the initial value as u1 is equals to u2 equals to u3, u4 equals to 0. u1 is equals to 0 plus 1 plus 1 plus 0, because 0 is u4 is 0 and u2 over 4 is equals to 0.5. Now for u2, we have u1 is 0.5 and our u4 is 0. 4 plus 0.5 plus 2 plus 0 divided by 4 is equals to 1.625. And for u3, u1 is equal to 0.5 and also u4 is 0. u3 is equals to 0 plus 2 plus 0.5 plus 4 divide 4 is 1.625. And for u4, u2 is equals to 1.625 and u3 is 1.625. u4 is 5 plus 1.625 plus 1.625 plus 5 over 4 is equals to 3.3125. You see, and next step is iteration number 2. First, we need to take the value of u1, u2, u3, u4. We can get earlier, u1 is 0.5, u2 is 1.625, u3 is 1.605, and u4 is 3.3125. Now, next is we're going to use again Seidel method. by using the value of u1 to u4. Our u1 is equals to 1 over 4 times u2 plus 1 plus 1 plus u3 is equals to 1.3125. This is u4. Now, take u1 is equals to 1.3125 and u4 is 3.3125, and to get u2 is 1/4 1 over 4 times 4 plus u1 plus 2 plus u4. Substitute the value to u1 and u4, we can get 2.6562. And for u3, 1 over 4 times u4 plus 2 plus u1 plus 4. We substitute the u1 and u4 to this, we can get 2.6562. And for u4, 1 over 4 times 5 plus u3 plus u2 plus 5. By using this u2 and u3, we can get 3.8281. Next, in tabulated form, we can input all the values we get to this table. u1, u2, u3, u4, and max error. We can input all the values to get the max error. We need to answer this using this formula: relative error by u new minus u old over u new. For example, u new is 1.3125 minus 0.5000 over 1.3125 is equal to 0.6190. And we already solved the 7th left in this table. By solving this table, we can get the value of u1, u2, u3, and u4. And u1 is equals to 2, and u2 is equals to 3, u3 is equals to 3, and u4 is equals to 4.
So, after natin ma-solve yung solution ng ating problem by using Gauss-Seidel method, so now isosolve naman natin siya gamit yung Jupyter Notebook or yung Python Notebook. So, before tayo mag-proceed sa Python Notebook, is i-derive muna natin ang ating 4 equation na nandun sa problem. So, given itong equation doon, madiderive natin itong ating equation 1 na 4u1 minus u2 minus u3 is equals to 2. So, magiging equation 1 natin yan. And madiderive din natin yung ating equation 2, which is negative u1 plus 4u2 minus u4 equals to 6. And so on and so forth, hanggang sa maderive natin yung equation 3 and equation 4. So, as simple as derivation lang. And gamit itong ating 4 equations, so for 4 unknowns, is magkakaroon tayo ng ating matrix, which is ito na siya. Yan. So, for example, dito sa ating equation 4. So, equation 4. So, matrix, which is wala tayong u1, which is 0. And ang ating u2 is negative 1. Ito siya, negative 1. And ang ating u3 is negative 1 also. Yan siya. And ang ating u4 is positive 4. Ito siya. and the coefficient is 10. So the same application is gagawin natin dito sa the rest na matrices. So ito na ang ating matrix ngayon. So ngayon na na-plot na natin yung ating matrix and ating 4 equations, proceed tayo dito sa ating Python notebook, which is solve na natin yung problem involving partial differential equation. So first is kailangan nating mag-import ng mga kakailanganin nating modules like SemPy. Import natin dyan yung printing. So itong printing na to is gagamitin natin siya para ma-present or mapakita yung ating equation, which is meron tayong 4 na equation. Yan yung mag-i-encode ng ating equation. So next, itong system naman na to is yung gagamitin natin siya para ma-solve yung ating matrix. So hindi na pala to kailangan. Kasi in this code, gagamitin lang natin yung SemPy. Yan. So we will import SemPy as SP. So next is i-define na natin ang ating 4 na equation, which is SemPy function and equation 1. So the rest, the same will apply sa mga natitira. So copy na lang natin siya. Then change tayo ng sub number. As function to So next is, after natin ma-define yung ating 4 na equation, is i-define naman natin ang ating 4 na unknown, which is ang ating 4 na variables, which is U1, U2, U3, and U4. So that would be yan yung magiging ating symbols. So next, after natin ma-define ang ating equations and ating variables, ilalagay na natin yung ating equation. So ating equation na equation 1, this one. Yan yung ating equation 1 ito. 4 times u1 is u1 minus u2 minus u3 equals, so yung comma na to, ito, that will serve as the equal, so equal to 2. So next equation, minus u2 for u1 minus u2 minus u3 2. Next is equation 2. Equation negative u1 and equation 2, negative u1 plus 4 multiplied by u2 minus u4 equal to 6. 6 4 u2 negative u1 plus 4 u2 minus u4 equals to 6. So next equation 3, negative u1 plus 4 u3 multiplied by u3 negative u1 plus 4 u3 minus u4. This is equals also to 6. Next, equation 4. Check muna natin equation 3, negative u1 plus 4 u3 minus u4 equals to 6. So next, equation 4 equals to negative u2 minus u3 plus 4 multiplied by u4 equals to 10. Negative u2 minus u3 plus 4 u4 equals to 10. Okay, so next is we will proceed to our variables, which is ilalagay natin yung ating matrix row. But before that, we could display, pwede pala natin ipakita, no? Pwede natin ipakita yung ating each equation, yung ating apat na equation. Equation 1. Yan. Para makita natin siya sa result. 2. 3. And equation 4. Yan. So, next is, i-input na natin yung ating matrix, which is ito na. So, let's say row 1. Ito. Yan. Magiging row 1 natin is 4, negative 1, negative 1, 0, 2. 4, negative 1, negative 1, 0, 2. Row 2 is negative 1, 4, 0, negative 1. Negative 1, 4, 0, negative 1, 6. Negative 1, 4, 0, negative 1, 6. So, 1, row 3, negative 1, 0, 4, negative 1, and 6. Negative 1, 0, 4, negative 1, 6. And last is row 4, 0, negative 1, negative 1, 4, and 10. 4, negative 1, negative 1, 4, 10. So next is to solve for the matrix. Isosolve na natin ngayon yung ating matrix. System. So system, matrix. Matrix. Which is, sa loob ng matrix natin, yung ating bawat row. Row 1, row 1, row 2, row 3, row 4, is comma. Matrix, row 1, row 2, row 3, row 4. Next is to solve for the linear matrix. So linear system. So linear system, which is ang ating system din. System at yung gusto nating mahanap, na value, which is our four unknowns, U1, U2, ulit, comma, U2, comma, U3, comma, U4, U1, U2, U3, U4. So, ito na yung end ng ating codes. Last na gagawin na lang natin is i-run siya. So, merong mali. Name error. Name printing, init printing is not defined. Mali. This one is mali. Dapat pala siya ituldok. So, try natin ulit siya i-run. Yung mali ulit. Siyempre has no attribute function. Miss. This one. Function dapat na function. 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 Antok na, antok. Last na. There we go. So, ito na yung lumabas na result. Yan. So, ito yung ating for equation na nandito. Yan. For U1 minus U2 minus U3 is equals to 2. equation 1, and so on and so forth. Apat na equation and 4 unknowns, which is ito din ang ating result doon sa ating manual calculation using Gauss-Seidel method. Ito yung lumabas na result sa ating last iteration. So same answer. And that would be all for this presentation.